Okay, well, great. Yeah, thanks again for coming. So today I'm going to talk a little bit about WebVR and specifically a framework called AFrame, and then more specifically how some best practices I found while working with it and reading about things for making cross-platform applications that would work in a VR headset if you have one, or on another device if you don't. And then also, again, thanks for joining the hopefully a first of a long-running series of lunch talks. Bruno's queued up next in a couple of weeks. And hopefully this will be a fun way for people to share things they're into, maybe things that are valuable, maybe things that are just cool, and I'll learn a couple of new things. All right, but for now, let's talk about VR. So how's VR doing in 2020? Okay, I think is the answer. It's one of those things that always has been about 5 years away for a while now. So this was interesting. The Steam, which if you're not familiar is like a big game platform for computers, released that recently they just passed 1 million monthly connected headset users. So that's everything from the Oculus Rift to smaller things like the Oculus Go, but yeah, so they just hit 1 million with the release of their big game Half-Life Alyx. And so on the one hand, that's a lot of people. 1 million people is a big target audience. And that means if you make something for VR, then there's at least 1 million people that could check it out. But on the other hand, that's like less than 2% of their user base. And their user base are people who play PC games, so that's already people much more likely than the general population to have one of these things. So basically what that means is that there is a dedicated and a pretty early adopter interested user base for VR apps. But if you want something that many people will see, almost all of your potential customers are not gonna be able to put on a headset in hands and do something with it. So the interesting use case then is if you want to build something that's maybe a little buzzy and is cool, that it can be in VR, but that also more than just these core 1 million people can experience. And if you happen to be someone that works, say, at a web development company and is familiar with that sort of technology, then you are the ideal target market for AFrame. So AFrame it's a WebVR framework from Mozilla that they released in 2015. So if they thought that VR was 5 years away, then they were a little optimistic, but that's all right. So it's been out for 5 years. It's under active development. Still, the landscape is changing a little bit right now. The web browser standard WebVR is actually deprecated, and it's now called WebXR because it now supports AR as well as VR on mobile. And so AFrame just released in February their 1.0.4 release, which supports WebXR, which is important because if you accidentally follow a tutorial that tells you to use 1.0.3, nothing will work on any browser and it'll be very confusing. So keep an eye out for that. But yeah, I guess that's why we use frameworks to keep up with all these little changes in the web standards world. So what is it? Well, here it is. This is the sort of hello world of AFrame. This is an iframe with AFrame in it, a lot of frames. So we've just got a 3D model, boxes, sphere, cylinder that you can look around with. If you click this button, it would go full screen because I'm using my Mac, so there's no headset attached. Yeah, so relatively simple, but how does one make this in AFrame? So it's very straightforward. AFrame is built around Three.js, which is a popular JavaScript library for doing 3D rendering, but it's fairly low level, and there's a lot of work to actually get it to be something kind of useful. So AFrame builds on top of that by using a HTML-based model, so it kind of feels familiar to web developers. So you can see we've got things like got some custom tags for an overall scene, which corresponds to a Three.js scene, and then the box, sphere, and cylinder and a flat plane that we saw in the little demo are all just described as elements that have some properties that describe their shape and position and that sort of thing. So and then of course, most importantly, 1.0.4 AFrame on the top there. So at a really high level, the neat thing with this is that it lets you use the kind of thinking that you're used to with HTML, and you can have nested elements, and a nested element inherits its parent's position and rotation. So like if this box had some things inside of it and you move the box, everything inside of it would also move, just like a div, an absolutely positioned div or something. So it's the same kind of paradigm of little elements that can be composed. And it's very declarative, right? Box, sphere, cylinder, and then back here, we've got the box, the sphere, and the cylinder. So it's a nice way to kind of organize your entities. And because you may like this, there's a React wrapper around this. So here's the same component, but or the same markup, but in a React component. The React wrapper is really nice. I like using it just because it's handy for state management, and like all the React tooling is sort of good. I want to point out that it's also a real potential foot gun. The big difference between VR and like 3D in general and the 2D web development and app development that we're more used to is memory management is much more important in 3D stuff. For a VR to be a really good experience, it has to be running at 90 frames per second, which means that you have what is like 10 milliseconds per tick to process. And the big thing there is that if you instantiate any variables, then basically if you do any functional programming inside your tick handler, then you're going to run into garbage collection problems because you're creating variables or you're allocating memory that needs to be deallocated, which you don't want to do because it'll break your render loop, or it'll slow it down. So you use React for high level, like somebody clicked on a button and I want to let a few other components know. That's really good. You definitely don't want to use React for anything that's happening more than once a second or something like that, and probably less than that, just like sort of random user events. So as long as you stick to let React do what it's good at, which is message passing and setting up hierarchy, and then you let AFrame do most of the work of actually doing the animation, then you're going to be in a good place. Okay, so we made some boxes, that's fine, but if anyone's going to use it, then they should do something. So in AFrame, the way that you make things do things is this paradigm called ECS, Entity Component System, which comes from Unity and like game development land. So there are three basic kind of things in AFrame. Entities are the tags, like a box for a box that have some really basic styling and shape. In practice, you end up mostly just using a entity, which is sort of the div of AFrame, where it's just kind of an empty wrapper that you can do whatever you want with it. You can turn it into a shape or a 3D model. Google Poly has a bunch of free 3D models that you can pull into your creations. But yeah, so it's just like the actual physical thing. And then components are sort of the main workhorse of AFrame. They do most of the work of setting up logic, setting up styling, inter-component communication. And the name is funny because it's means something completely different than it does in React. Like in React and modern web frameworks, a component is something that has logic and styling put together. In an ECS paradigm, it's just logic. It's more like a controller. And the way they work is you attach a component to an entity by using it like a HTML attribute. So position, for instance, that tells it where the thing should be in the world relative to its parent, is actually a component. So like here, we see that position, it's getting set to some XYZ value. That is going to trigger some code that will actually dive into the object model and do things to make it the right shape. There are other more complicated components, like there's a built-in called laser controls that if you attach that component to the hand entity, then you'll have a laser coming out of your hand that you can use to click on things and interact with things. So there's all kinds of components, and most of the logic, anything that's happening with a tick handler or needs access to the actual objects, like the 3D objects, is going to be stuck in a ECS AFrame component. And so a component, we'll see a little bit more exactly how that works in a second. And finally, a system. The S is system, which is the singletons that get spun up that are attached to a given component type. So everybody that has the collider component, for instance, will have access to the same instance of the collider system, which you can use to tell if two things are running into each other or not. So systems are good for things like physics, collision, or just they can also be used for just having a place to put code that you don't want to put into the component, like helper functions. Okay, so because this is the workhorse, we'll talk about components slightly more detail, and then this is, I believe, the last piece of code that we'll see, and then we'll start talking about how to actually use this in practice. So component, right, it's basically like a little class that has a few pieces. You've got the schema defines essentially the props, like the inputs that you can pass to the component as, what do you call it? Semicolon delimited, just like you would pass things to a style tag if you were doing it in raw HTML. And so you give it a type. Okay, so in this case, it's a component for a door. Maybe we have a door 3D model, and we want it to be able to open and close when the state changes. So if the state can be open or closed, then that'll trigger some work. So you've got your props. Then you've got a series of lifecycle handlers. So you have things like update that gets called whenever the props change. So if open changes and now the door is open, then maybe we want to play some sound of like a creaking open sound. And if it's changed to close, then maybe we want to play a slamming sound, something like that. Something that happens as soon as the data changes. The other big lifecycle handler is tick. This is the one that fires 90 times a second. And so this would be good for if you want the door to close over a second, say, then you have the delta, which says how long it's been since the last tick, and you can use that to animate. There we go. That's what I wanted. You can use that to animate something over a period of time. So every time it ticks, it closes just a little bit more, and so it'll feel like a smooth motion. Yeah, that one. Okay. Other handlers are things like init, where you can set up variables to use or pre-configure things, sort of like the constructor, and things like onDestroy. You can also set up event handlers in here, things like when there's a raycaster event on this that triggers a click or a collision, do something. So all of that gets handled in the component. All right. Okay, so that's sort of how it works at a very simple, high level. So the question is why? Why do this? There's things like Unity exist that are perhaps a more powerful way to build like full-on games and VR experiences that people install on their computers, and maybe the textures are a little nicer. I think the basic reason to do this is the same reason that we make web apps instead of desktop applications. Like, it's cross-platform, it works on any device. You don't have to worry about an app store. It's just a URL, You go to it, and then you experience the thing. And because it's built with web technology, if you're somebody who uses web technology in your daily job, then it's nice not to have to learn a whole new paradigm. You can use the tools that you're already used to: Webpack, VS Code, React, whatever. Right. So to get more into the cross-platform thing, specifically, you can kind of break down the possible use cases of this into 4 discrete types. There's the desktop user that has a laptop or a desktop, like a big flat screen where they have a keyboard and a mouse that they can use for interaction. Then there's the mobile case. In mobile, the way it works is you have it's what they call magic window mode. So you have your phone, and it basically acts like it's a little portal into a virtual world. So if you move the phone around, your viewport point changes. But basically, all you can do is look around and then tap, and maybe that'll trigger something or let you move forward. But it's a pretty simple use case or interaction mode. Then, as you go up in interaction, you have the 3 degrees of freedom headsets. These are things like Google Cardboard or something a little nicer, the Oculus Go, where what you're missing are hands that can go, and a head that can go forward and backward. You don't have position. All you have is rotation. So you can turn your head. You can, if you have a remote control, maybe you can turn that and fire a laser, but you can't like reach out and touch a button. So all you can do is fire lasers out to interact with things. And that's kind of a sweet spot for AFrame. It's really built for, it has this model of, it's easy to set up this raycaster coming out of your hand or out of the screen. And if it touches something and you do some interaction, then it triggers a click event on that thing. So it feels a lot like web programming in that way. And then the final use case is the all up 6 degrees of freedom headset, where you can, or what sometimes like room scale, you can walk around a little bit, you can reach out, you can grab things, you've got a lot of buttons, and you can really build the most immersive experience there. But anything you build for that, nobody else is going to be able to use. So that's sort of the trade-off that we're going to talk about here. Okay, so that's a lot of talk. Let's meet a robot. There we go. Nice. Okay, so this is RoboBuddy, which is a little side project I've been working on the weekends. I like to think of it as the next version from the little robot that sat on my desk at work while we still were there. And so the way this works is you get the mouse control goes into the screen. And by the way, yeah, again, this is just a iframe. He kind of wanders around, but he is like a little cat. So I can click my mouse to fire off a laser pointer. And if he sees the laser pointer, then he chases it, because that's what this robot does. And if he loses the laser pointer, then he starts searching for it again. And if he sees it, then he kind of gets focused on it. And then after a second, chases after it. That's basically it right now. This is mostly just a thing to play around with AFrame, but it's sort of fun. I'll send the link out after if you want to play with it. But there are a bunch of things to notice here. The first one is when I hit the escape key, it pauses the game and I get a little pop-up menu. So because we're in desktop mode, this is a computer, it's flat. And there is a tool that's really good for building user interfaces on computers, and it's a website. So it makes sense to use the best tool at hand for the use case. So in this case, this is actually just a normal React component fixed positioned in front of the canvas that's rendering the 3D view. So in like a normal video game or something, you'd have to build this thing with the same tools as the rest of the game. But because we are in a web browser, we don't have to. We can just use the best tools for the job. This is really nice because you can do things like hover effects and all the things that you want to do to make a nice user interface. And it's also responsive. The VR game doesn't really know, or the 3D engine doesn't know, at least as easily, the size of the screen that's rendering it. So if you render this as an object in the 3D world and then you tried to look at it on your phone, maybe it would get cut off on the sides. But because it's web, we can just render it normally. And because we're using React to render this in AFrame, it's all connected to the same data store. So it just kind of works seamlessly. The other nice thing specifically about having this be sort of a pop-up is the way that there's a community control for AFrame called, or maybe it's a built-in called look controls, that when you turn it on, it takes mouse pointer control, and so you can just move your mouse around to look, and you hit escape to exit that. Is like the way the browser works. You can't get around that. And it's a pretty normal, you hit escape to get out of something. So by adding a couple of listeners to know when you're going in and out of lock mode and then showing this menu, you can use the existing browser tools to give the user a good experience where when they can't move around, it's paused, and now they have their mouse free to click on stuff. Once they start playing, the menu goes away and they can go back to playing the game. What else did I want to mention here? Maybe worth noting that this thing can also interact more freely with the game. Like he has a little come here function that'll make the robot come get a pet, and click that, and then he'll come to me. I can also walk around with arrow keys, which is just a built-in thing, and so we can kind of walk around and he'll chase me around here until he sees a laser, and then I'll go do something else. Unrelated to the VR, but it's kind of fun that.
What did you mean by built-in thing? What is that?
Oh, like the AFrame comes with a bunch of components. That's a good question. Thanks. One of them is movement controls. It's like WAS controls that you stick in as a component on the user camera, and it just starts listening to keyboard controls to let you walk around. And then if you're on mobile, it listens to tap events, and if you hold down the screen, then you'll walk forward.
Is there like any teleportation type of things like that they have on games?
Yeah. There are some community components for teleportation. Yeah, if you want to do the thing where you put out your hand and jump over to somewhere else. There's also like somebody has a checkpoint system where you can have certain pre-built areas that you can jump between, which sometimes can be useful if it's a more like directed experience. Yeah, so there are a lot of movement options, but those are some of those kind of easy to implement ones. Oh, right, and speaking of community components, this kind of cool desert arches thing is also just a component called, I think, AFrame environments. But there's a bunch of these procedurally generated environments that you can have deserts, forests, alien worlds, volcanoes, all kinds of weird stuff. And it's because they're pretty low texture and mostly procedurally generated, they're very lightweight. So it's a fun way to just like add a scene, and it's got lighting and everything else. You can see also that he's got a little light on his head that shows the state of the finite state machine that I'm using to figure out what the robot's doing. It's red if it's chasing, it's blue if you found it. And that thing casts a little bit of light that interacts with the rest of the scene, which is all just part of, like, lights are one of the built-in primitives.
Is there any physics built in?
There's
like picking up objects and gravity and things?
It's not built in, but there are a bunch of different community components for, there's like a hand controls, super hands, I think it's called, that can be built for picking up and grabbing things. On this one, we'll see in a second, I implemented just a simple collider to let you click buttons with your hand, which we'll see in a sec. All right, so, which is a good segue, and want to keep this moving so this all works great on web, but in VR, you can't see a DOM element. Like it doesn't work. So you need something different in VR. So I'll have to say goodbye to our robot friend here and move on to so that's flat screen. How do you handle the same kind of interactions in VR? So the big thing to think about is, right, there's no DOM elements, but you don't have to worry about responsive. It's always a 360-degree view. So that makes things easier. The but like a HUD, a static, something static that moves along with your face is considered bad practice in VR because that's not something that happens in the real world. I think that in the future, if we all have AR glasses, that best practice may change. But for now, it's sort of immersion breaking to have something fall on your face. So instead, it's considered best practice to either have it integrated with the environment somehow, like it's a physical control panel or a TV screen on a wall, or something that is related to your hands. So like a menu that'll pop out of your hand, you can pull that out, or something that I like, and we'll see in a second, is that when you turn your hand over, you get a menu on top of it. So that way you have a little bit of control, but it's kind of integrated into your environment, and that can feel a little better than something that's a little bit more obviously just kind of floating in front of you. Yeah, so let's see that. So here's a very simple implementation of that, where there's a little component that detects the orientation of your hand, which after a lot of research, it turns out is very simple math, but only once you find the right math, something with, I don't know, Eulers and vectors and things. But once you get it all figured out, it's straightforward to figure out. And so if your hand is about upright, then it shows a little menu, and the menu component is just a child of the hand, so it's always tied to where the hand is. And the interaction model is interesting. So here we can see that there it goes, that there's a touch component here, where if set of a collider system, and so if it detects that the hand has collided with one of the buttons, then it triggers whatever the button is supposed to do. That works really well for the 6 degrees of freedom headsets like Oculus Rift. It does not work for a Google Cardboard or a Go, where you can't push your hand back and forth. So for that, it also is going to support a raycaster coming out of your hand that you can point it at the button, click some button, and it'll trigger a click, which will do the thing. So this is the kind of like balance between, you want the best experience possible for the high-end sets, because like that's what you're there for, is like really interactive stuff. But you also want to support everybody else if you want them to be able to experience your thing at all without just saying, yeah, it's broken. Ideally, they're like, maybe the button would get pushed in or something. Like you can make this as nice as you want. The other thing is, for the 3 degrees of freedom people, of course, this hand thing doesn't work because they don't have a hand. So the way it's set up in this app is, if you're on browser or mobile, you get the controls from HTML. If you're on a Google Cardboard, it's just a static thing that's doesn't move with your head. It's just like floating off to the side. So you look over at it and you can see your options, kind of unobtrusive. And then for the people with hands, you actually get the hand controls. So things to keep in mind with when building this kind of thing is
Going back, sorry,
yeah.
going back to that previous thing, what
Yeah.
is it? Like, are you controlling this right now in VR? Like,
what yeah, sorry, that probably could use some explanation. This is just a GIF. And specifically, it's a GIF of, and this is a really cool tool. There's a Firefox extension and a Chrome extension called WebVR emulator. And it lets you physically, like in the dev tools, it lets you place a headset and hands, switch to VR mode, and then while using your computer, you can manipulate the location of the hands and headset. So you can test out VR stuff without actually putting a headset on. We can probably see that pretty fast here. Oh, no, it's got it in Firefox. There we go. So, right, once this loads up, you can switch to VR mode, and then I've got this headset that I can turn, and I see my hands, and I can move those around. Ooh, not bad, just this. So, all right, well, I don't know why that's not working. It usually is. Anyway, yeah, so that's where, so I just took a GIF of doing that. Does that make sense?
Yeah, it does. Thanks.
Yeah, for sure. Yeah, this is definitely like in the end, if you want to have a headset so you can test things out, but it's nice to check interactions ahead of time, and for testing things like when the hand is exactly this way, it should do this. So yeah, so this is just if the user pushes their hand through the button, then it triggers the button, and you can see his little light goes from green to purple to show that he's in come back mode. Right. Okay. So kind of wrapping up, the things to keep in mind when building cross-platform experiences in 3D is that the user could have between 0 and 2 hands, depending on if they just have a headset, if they've got one controller, or if they have 2 movable hands. Those hands could go forward or backward, or they cannot. Raycasters, firing the laser, is a good way to handle all the possible use cases, but feels a little less immersive for full-on 6 degrees of freedom users. Discoverability is also something to keep in mind. Like the switching your hand over thing is kind of neat, but only once you know about it. If you don't, maybe it would take you a while to happen to put your hand in a weird position. So some kind of tooltip or something, or a little something that glows in your hand to tell you that you need to do something with it would be useful there. And talking about weird positions, something else that's sort of a weird thing to think about is actual physical comfort. Like this thing where you turn your hand over works because you're only expecting the user to do a really short interaction. And so for that, it's really nice. You do something quick, it pops up, you interact with it, and then it goes away without having to like click a bunch of buttons. But if it was a big menu that you expected the user to spend 10 minutes clicking through, they would be really mad at you if they had to spend a whole 10 minutes with their hand like awkwardly up the entire time. So for something like that, maybe you would choose something that existed in the environment, or just like a big pop-up that came in front of the user's face. Even if it's a little less immersive, it would be more comfortable to use. And finally, you want to think about handedness, making sure that that things are attached to their dominant hand rather than their right hand specifically. Yeah. Okay, and just to wrap up, things I'd like to see moving forward, like I think that the WebVR stuff is interesting. I think the particularly powerful use cases are because we're in this situation where you have some people with the really cool hardware, but most people don't. Asymmetric experiences seem really interesting. Something like there's a game that came out recently where one person in VR is like a monster, and then their friends can play from their computers as I think it's like pilots of little airplanes that can shoot at the monster, that kind of thing. So something where you can take advantage of the fact that some people have this cool technology that lets them be a little more interactive, but then they can interact with their friends who don't necessarily own the same hardware. Also collaboration tools in games, things where you can come in from whatever device you have, and it's mostly about, social interaction with your friends. This can be a good tool for that because you don't have to convince your friends to like install Steam and buy a game or whatever. You can just like throw together something on a Zoom call, and you can all mess with some little game for a few minutes in whatever device you have. And then tech demos, things where you want people to know that you've built this cool VR thing, but if they don't have it, you want to give them something to like see, to get a glimpse as to what you're working on. Then this would be a good use case or a good tech for that. Or something like prototypes, where you're not sure if it's going to be a VR experience or a web experience, and you kind of want to play with it. This can be a good way to get something working and get it out to a lot of people really quickly, and then decide what you want to do with maybe like a more full use or a full game or something. Yeah, so that's pretty much it. That was just sort of a short dive into what's possible with the tech and how you might use it. And I would love to see somebody do something cool with it. Yeah, I guess that's it. If anyone has questions, do that for a few minutes and then wrap us up.
What's the coolest thing you've seen so far that someone's built?
Oh yeah, that's a good question. Let's see. There's actually this browser called SuperFrame or SuperMedium, which is the people who built all the SuperFrame extensions that you can get on like the Oculus, and that has some curated experiences. And so there's some neat things on there. Like there's somebody built something that's like Beat Saber, but instead of whatever with the saber, you're punching the dots coming at you. The one that's fun about that is that you have robot backup dancers, basically. That they're like 4 robots next to you that are all dancing in time to your actions. So you feel like you're part of like a dance sort of dance group, but you know, of course, they're just using your motion tracking. That was a fun one, and was a AFrame tech. So that was a good one. But I've seen a few demos with using WebRTC to do multi-user experiences where you can have multiple people in the same VR app that can see each other and maybe talk to each other, which I think is, I messed with a little bit, and WebRTC is really, really hard to get right, but surprisingly complicated. But that feels like the real best use case here is like these collaborative, interactive things where people are coming from what they have and like seeing each other in almost real life. Any other questions or anything?
What's sort of like app size for when it like the minimum if you include all these all the libraries in this bundle then?
It's a really good question. Let's see. All right, so AFrame itself, oh, of course, is memory cache, what, a megabyte of code, which is a decent amount. In the end, the code ends up not being the biggest the part of memory. Once you build any kind of, it's mostly going to be the 3D objects and textures if you sort of opt into those. This is mostly just primitive boxes and stuff, so it's pretty lightweight. But the way AFrame works is that when you load the page, you get this loading screen, and there's like an asset management system where you declare up front all of the 3D objects and sounds and things that you want to load before the game can start. And they all load while you're in that blue state, so that by the time you get into the app, it's all ready to go. So that's where a lot of the loading happens, and then the app itself can feel kind of snappy. The interesting thing with the asset management system, because it's just a website, like in this case, this is basically a single page app, but you can also use like a more traditional server rendered app, like a Rails app or whatever, to render this thing. And then if you have user accounts, like you can do things like decide based on the user chosen avatar, so we should only load that asset. And you just do that by changing the HTML that you serve. Like it's just because it's just an app. So that can be neat. When I was playing with using this for generating 3D talks, like that's what I was doing. But based on your user account, we would load just the information for you, but then do it at render time so that loading screen would render the right audio for the talk, that kind of thing.
Does this stuff make sense at all in an AR application, or would that never?
Yeah. They're just starting to support it. I just saw a blog post from Mozilla maybe last month that they added full support for AR, and they had some early use cases with, like, I don't know, watching butterflies fly through like a city street. It basically only really makes sense on mobile. And in fact, when you go to an AFrame app by default, there's a VR button on desktop, but if you go to mobile, there's a VR and an AR button next to each other,
Cool.
which you can configure. But yeah, so that's starting to become a thing. It seems like a cool way to build those experiences easily. Oh, I do want to mention, because the next one of these is, I think Bruno talking about TypeScript and how he's never going back to JavaScript. AFrame has some TypeScript types, but they're only okay. I've been working on a few more that let me build the components in like a strongly typed way. So it is possible to do it with TypeScript. If anyone actually gets into it, let me know. I'll send you a definition file. And it definitely helps managing all the weird little props and things. All right, got the thumbs up from Bruno. All right, cool. Well, I've got probably time for one more question. Probably call it at 12:45 here. Otherwise, let you all get back to your lunch. Cool. All right. Well, thanks very much, everyone. Happy Friday. Have a good weekend.
Thanks so much, Will.
Thanks.
Thank you,
That was great.
Cool.
Thanks a lot.
Oh, thanks.
Yep. Great talk.
Thanks.